Hello, everyone, and welcome. Thank you all for joining us today for this live stream event. My name is Adbina, and I'm the Program Manager of the Microsoft Reactor San Francisco. I'll be sharing session resources with you in the chat, but before we begin, I would like to quickly review two items with you, our Code of Conduct and our event guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link in the chat for our YouTube channel. And before we begin, let's bring Sam. And we're having for the testing your application, the Reactor Code Lab. Hello, Sam.
Hello, thank you and welcome everybody. Today we're going to be taking a look at testing. So there's lots of different things people mean when they talk about testing. In this case, we're going to be taking kind of a overall look at testing and also taking a look at how I'm testing a current project I'm working in. And then we can kind of work from there to kind of explore a little bit more about what this is and why this is useful. When you talk about testing, there's typically you'll typically see a testing pyramid. And what that is usually intended to describe the differentiation between the types of tests that you're creating and how you're using them. So a lot of the times you'll see things like unit tests versus integration tests versus end-to-end tests and so on. There are a lot of different types of testing that you can do. But typically when we're talking about software testing, those are the three that we're kind of focusing on. And then a lot of other things like performance testing, compliance testing, things like that are kind of branches of one of those type topics. Usually end-to-end or integration tests that are kind of focused on certain things, whether that's performance or some other requirement. What tests do is give you a way to automatically validate your software and make sure that the results that you're getting are consistent and can be reproduced. So typically when we talk about a unit test, we're testing a unit of code, typically one function or one behavior in your application. And ideally, these are shrunken down. So when we talk about a testing pyramid, that bottom layer, the really wide one, is your unit tests. And the idea there is you want lots of tests at really granular levels because the goal behind a unit test is to tell you what is broken. So you don't have to go and search for it. Because if you have a very large application, a like storefront, for example, and somebody says, I can't buy something, okay, how? How do you figure out what's broken and why that isn't working? And just saying it doesn't work doesn't give you the information you need to actually figure out what doesn't work. The advantage of something like a unit test is it tells you this function returns the wrong results when we do this and this. As you start growing the scope of that test, what you end up running into is something like an integration test or an end-to-end test. And those increase the complexity of what you're trying to build. And that also means that the granularity of the detail that you're getting about the failure in your system isn't as clear. You don't always learn what's not working because of that. So this gives you a little bit of another different way. Let's pull this up. So we have some actual docs walking through how all of the testing stuff works. So this is a great place for you to get started if you're looking to learn a little bit more about testing. We're going to kind of build off of this as we move through this and talk a little bit more about everything else. But what this is doing is giving us this rundown of how all of these different tests work. You will see different differentiations between what type of thing a unit is or a unit test is versus an integration test versus an end-to-end test. The classification isn't that useful beyond just discussing it with somebody else. Where a unit test versus an end-to-end test gets useful is in scope. Talking about what your test is covering, whether it's covering a specific part of a program or a user experience of a program or something like that. and how that works. So when you think of that testing pyramid, a lot of the useful thing that you'll get out of it is not so much from the layers of however many layers you put into that testing pyramid, but a lot more value can come from just thinking about having the smallest or lightest scope at that bottom level of your testing pyramid and making lots of those because they're easier to update, they're easier to maintain than the end-to-end tests. The reason for this is when we're talking about unit tests, if one thing changes, the only thing that needs to be updated is that unit test. Where can I find these docs? At aka.ms/testercode, you'll get here and be able to kind of walk through this. If there's questions you have about them, please feel free to ask me, and I am happy to talk more. This is part of the Reactor Code Lab series. It is intentionally sort of a more freeform thing. So what we're doing is actually looking at a application that I have been building. We will dive a little bit deeper into how all of this works over time, but I've been in the process of putting this project under test. And so it seemed like a good time to talk a little bit more about how we test things. So that's where that is. Hopefully that's helpful. We'll be talking a little bit more about some of these other things. And the terminology that you'll see across the testing world will change depending on who you talk to. This is not super concrete stuff. Especially when you start talking about the differentiation between an integration test and an end-to-end test and what that means. It's kind of hand-wavy as far as how all of that works. I don't even think this doc mentions end-to-end tests. It's just not there. And that's because a lot of that is more integration stuff. So how this ends up working is unit tests are describing a unit of work. So let's go and actually look at some of my code and see what's happening. So in this case, I'm testing a get hints function. So this is a game that I'm building for just a test thing to learn some Blazor and SignalR stuff. We're not going to talk about any of that until maybe a little bit later. But all this function is doing is testing this get hints function. That's what it's intended to do. And so the way I like to structure my tests, and this is largely inspired by Spock, which is a unit testing or testing framework for the JDK and Java, is using a given, where, and then expect clause. So there's no actual meaning here. They are not required. But what it does is it says, given a specific state of my program, in this case, we're creating a set of current data, in this case, a series of hints. And then what I want to do is run one specific function. So where is the action? That is the thing that is happening. That's going to change the state. It's going to return some result. It's going to make some computation. It's going to do something. And then when we run this, we're going to get a result and expect that result to be some value. That's how our testing flow tends to work. So given some state, do something, expect that state to now be this. And that can just be repeated over and over and over again. So that's how this ends up working. And in this case, we just have a series of asserts. Some people will argue that you should only have one assertion per test. I found that ends up making very verbose testing. And I have run into issues with that. One of the anti-patterns that you can run into with this entire idea of testing is over-testing. What that means is writing a test for every part of your code. The reason that's a problem is because tests contribute to your technical debt. Technical debt is like a credit card. So it's something where you can charge money to it and take out credit against something. And then with the expectation that you will pay that back eventually. So in this case, we get our value back over time by writing tests because we no longer have to spend our time going through and manually validating that our code works. The downside is code changes all the time. This isn't something we're going to write it once and it's just going to stay that way forever. everything is going to be updated and changing and moving. And so we need this to be able to sustain itself, to be able to be updated and sort of continue to live with our service. That becomes difficult if every change to your service requires significant amounts of test changes. So you can run into issues where suddenly everything starts breaking. The term that I've used in the past has been flaky tests, which doesn't necessarily describe this, but what it does describe is a test that fails intermittently, something that is going to be run and then will pass. And then if you run it again, it's going to fail for no different reason than what you wrote. If we wanted to write one, because why not? We can just write a test. So quickly going through what this is, just because we're here. This is XUnit. This is an XUnit testing framework. There are a few different ones. There's MS Test, XUnit, and NUnit as the three main options that you'll have if you're working in .NET. A lot of the testing stuff that I'm talking about isn't specific to .NET. This is general stuff that you can apply to any project that you're working on, whether that's infrastructure stuff or Java stuff or Go stuff or .NET stuff. But the specific code and testing frameworks will be different. So anyway, let's make a flaky test. So if we want to do this, this will be our flaky test. The way this works is we're declaring a fact. XUnit has two different options. It has facts and it has theories. Fact is going to be describing a single instance of an event, versus a theory is going to work like this and describe a set of data, and that should hold true for whatever the thing is. So in this case, we're using inline data and just providing the data inline in our function. This is great, but breaks if we try to do any dynamic data. Your data inside of annotations has to be of compile time constant, so this doesn't work if you need it to be like a class, for example. So if we wanted to create some new thing, like a new name data, we can't do that here because it has to be a compile time constant. So that's just one of the cases here. This is a different example we'll talk about in just a little bit, but that's the other alternative to a fact. And all we're going to do here is do random. So given a random number generator, when we generate a random number, so our number is equal to random next between 0 and 1. So just two, well, should be exclusive. So 0 and 1 should be the two options. And then we can just assert this is, getting random things equal to our number. So we'll say this should be equal to 1, something like this. So this is not your typical way of getting a flaky test because it's obvious. We put it all in one place. The downside with this isn't usually how these appear. A lot of the times what will happen is you'll make a service that, for example, if we're talking about microservices, your application is going to call out to other applications. It's going to make requests to something else and ask for some information. It's going to connect to a database and ask for something to exist, something to happen. If you're talking to a database, that state may change. Somebody might go in and change the format of your tables, might delete some data, might insert some data. Things might be different, or maybe it just is run on a different computer. All of those things can contribute to a test failing for reasons that aren't the test being wrong. In this case, the test is just not correct. But what this does is show you a way to actually kind of generate this. So if we run this using CodeLens, you'll see we get this test running over in the left-hand side there. And we'll see it failed. We expected 1, we got 0. If I run this a few more times, eventually this test is going to pass. It just did. So what might happen is your test might validate locally on your own machine and then fail in CI, or it might work on your machine and in your CI processes to validate everything is good. And then when one of your coworkers pulls your code down, they'll realize that it doesn't work there. Those can contribute to flaky tests, and this can cause a lot of just difficulty. Another thing, our tests are unit tests right now. They're all relatively fast. They're all taking milliseconds to complete. That's great. The downside with this is if we have to make like a web request, if that web request is going to time out, it's going to take a couple minutes potentially to actually get us a result, which would just be a failure. Those kinds of issues can cause significant delays in the entire process of your application moving forward. Typically, the way the process for developing something like this works is you would make your change locally and then submit a pull request to Git or wherever your code is stored, and then automated tests would validate your change before that gets merged. One situation that can happen if you have long-running tests is somebody else can show up and merge a change before your test gets into the code base. When that happens, your code might no longer actually work. It might no longer reflect the state of the application that you're trying to actually update. And so having these quick turnaround times can be really quick or useful there to help clean some of that up. And it can also improve feedback times. One of the features that I really like, though unfortunately I believe this is only available to you inside of Visual Studio Enterprise, is the live testing feature. This is the live unit testing feature. What this does is if I click this run button, it's going to watch my code. So every time I make any change anywhere in my code, it will detect that and rerun the tests that were affected by that change. This is a little bit nicer than, for example, a .NET Watch, which I can show you in just a second. But what this will do is, let's go and break something. Well, we don't even have to leave this file to make this break. Let's just go here and change this to be spelled wrong, something like that. And all I did was save the file. And we should see, after a couple seconds, I hope, a test failure pop up. There we go. We now have our flaky test, which is still failing, but now our new test is also failing because we now have additional hints. What this is doing is removing duplicate values from a dictionary. All we've done is just change this test, so now it's failing. The cool thing with this is this gets you almost immediate feedback in a couple seconds. So we can fix this now and save it again. And in a few seconds, we should now have a passing thing. Also, our flaky test is now passing. So that's convenient. Everything is green. So now we have our code working. This feature is really handy for working on like larger projects, I've found, because you don't want to rerun all of your tests, especially if you have integration tests that can cause you to run a lot of things. With this, you can actually filter down just to the tests that you want to run, like unit tests that you might be working on, something like that, and it will just rerun the affected tests. But yeah, that's that. So there is our testing. We've quickly covered a lot of this. What else? I think that was mostly it. The other really handy thing is the code lens will also show you for each of your functions. It will show you the tests associated with it. We're already in testing files, so this is less useful. But if I actually go into like this get hints function, when this is a actual project I'm working on, so this is kind of a mess, but you can actually see the tests that are passing or even rerun them to actually test that things are working and run them. So there we go. And you can see the way this UI is indicating the filled in green check marks are the tests that were actually run. And there we go. So hopefully a little bit helpful. Another thing that I found really useful about this entire idea of testing is if you're a student or studying for something and need to submit like an assignment, tests give you a way to validate that your assignment is probably okay. It gives you a way to actually check this without having to manually go and run your thing and see if that's working. What I used to do when I was working on things and kind of learning to code is I would write a CLI program or something that would inject code automatically and sort of do this whole process manually. A test gives you a nice check mark to actually show that it's working, and you can actually kind of validate that a little bit nicer. So while we're still here, let's quickly jump over to, what did I okay, switched my view. Let's go here. So this is probably another useful thing to talk about when we're talking about testing. This function is a little bit different, and it's using a few things that we haven't talked about yet. So the cool thing is it's a theory. What that means is that we're injecting data into the arguments of this function, into the arguments of this test dynamically. These are going to, the format for this is going to be different from XUnit to NUnit to MS test. They're all slightly different and they'll behave a little bit differently, but a lot of them, the functionality is similar across all testing frameworks, at least the ones that I've used. So what this does is take, in this case, 0, 1, and 32 and plug it into our seed value. And then it also takes an expected output and plugs that into this string. And then we just compute an ID and compare that to the expected ID. So this gives us a way to actually validate that the result that we're getting matches what we're saying we should expect. And it allows us to duplicate the functionality of this test multiple times without having to rewrite the same thing. There's nothing wrong with doing something like this. Making a mess. So if we created this, I could go and plug in these values manually. Something like this. So just making everything unique. This is fine. The downside with this is this means keeping in mind the idea of technical debt as tests as technical debt. This causes a little bit more of that. It also means that it's very easy for me to come in and fix this test and break or leave the other one broken. So we no longer get the all the tests working together. This one should still pass if I've done this correctly, and it does. But now we have duplicate code where we're making more and more code that we have to maintain. And especially when you start getting into things that are more complicated, things like end-to-end tests that are going to be spinning up entire services and figuring out how to inject data and how to mock services, things like that, you'll start running into issues there that make this 3-line function seem a little bit nicer. Another really cool thing about how these pieces of code work is you might have seen or might have heard people describe their code as self-documenting. That's not always true, but one of the cool things that you do get out of a test is you do get some documentation for free. Not necessarily free, but it's part of the cost of building a test is also documenting your code. Because what that test is doing, what this test that I've written right here is saying is the hint list does not contain duplicate guesses from players. So when a player submits a guess, in this case, we have a collection of players making guesses. There's a duplicate that should be removed. That's what this test is testing. And so by describing that, anybody else who comes here and spends a little bit of time actually reading the tests and what's going on should see that that's how this is supposed to happen. But that's what is intended here. And it also means if somebody else comes in and wants to do work on this get hints function to validate that it's working and maybe doesn't think that we need to check for duplicates. This code I needed to update. But in this case, just wants to remove this where. So we're just going to always have all of our hints added in. If we want to do that, we can rerun our tests now, and things will get blocked. This change wouldn't be allowed into our code base because it automatically ran it. Neat. So we get a whole bunch of X's and things are not okay. In this case, we can even see, because we're working at the unit test level, we can actually see exactly what broke, because my change impacted exactly one thing, one part of the code, and that was the one that we were testing. So in this case, the hint list does not contain duplicate guesses. By removing that restriction inside of our code, we broke that test, and that test tells us exactly what broke. So in this case, it's just saying things aren't equal. We expected 2, and we saw 4 elements. So there is a little bit of inference that you have to make there, but because of the name of the test, we should actually be able to figure out what's broken just by looking at that test. We don't need to actually even know anything about what the code is or what's going on. Just by seeing that, we can know what isn't working. And that's probably one of the most powerful things about a test, is that it tells you that information and makes it clear to everybody else working on the project. Anybody else who runs this code is going to see the same thing. Even if they've never talked with me or anybody else who has written something for this project, it's still going to happen. So it's still going to validate that. And it's going to do that every single time we run a test. So every single time that I try to make a change or anything like that, we're still going to see all of that happen. Now, let's quickly talk about some other fun things you can do. Let's go and look at the .NET CLI. And this is another fun thing that I like to do when I'm running tests. And I actually have been using this a little bit more frequently, actually. So what we're going to do is actually look at .NET Watch. So if we actually go into project, let's go and do this. Sorry. There we go. If I go into my test project and run this, it doesn't work. 1 second. What am I missing? Do I just not need that? Okay. I'm getting a step ahead of myself and making mistakes. But if we run this, this is going to run our test project exactly like we were doing from Visual Studio, but we're going to be doing it from our command line. And in this case, we're going to get a series of failures, 4 failures, it looks like, for this issue. And we can actually see the different results that we're getting as part of that. So in this case, we have a whole bunch of things. We're still getting the same results as we would see in Visual Studio. In this case, it's expected and actual. So we can actually see all of these going on. We also get a stack trace associated with this, so we can actually see what line this is occurring on. In this case, this is going to be the assertion that failed inside of our project, so we can actually go there and figure out what's broken. And in this case, we have, looks like 4 different things. My change actually broke 4 things because we have 4 different tests validating different parts of the thing. But this gives you the same thing. What we can do from here is actually attach a watch. So doing something like this inside of this project, back to where I was initially. What this is going to do is actually watch for changes and actually rerun the command. So I've used this typically for like running a thing. So if you have a web server or something and you want to always have the latest version of it from the CLI, this gives you a way to kind of do that. You can also use this to test your applications. So in this case, it's going to establish a watch over the directory and then run the test. And we'll get the same results that we just had, but we'll also see waiting for file change before we're starting .NET. So now what's happening is this is just waiting for us to make any change. So what we can do is go back here to our thing that I broke. Here we go. And we'll put that where clause back. So all this is doing is just counting the occurrences of a word and then assigning that a value and then testing for only the ones with a value of 1. So only things that occur a single time. And then we are going to save that. And so by saving this, we actually reran that. I still have my flaky test, so let's go and delete that because we don't need that anymore. So we can just get rid of that. And this should rerun our tests again. So every time we're making changes to this, it's going and rerunning to validate that things are happening and giving us the results back. So you can use this wherever you have .NET, and it gives you this really nice kind of recurring cycle. The downside to this is it's going to rerun all of your tests. So if you have all of your tests in one place, in this case, I've just begun putting this project under test, so there aren't that many tests. It's not uncommon for a very large application, especially one that's been in production for a while, to have hundreds, thousands plus as far as tests go. And rerunning those every single time you make any code change at all might be a little bit much. This can be really handy, though, for things like microservices, where you have just one thing and you just want to rerun the unit tests, for example, and just validate that all of the behavior that's supposed to happen is happening. That's sort of the use that I've found for this. Otherwise, things like the live tester can be a little bit more fine-grained and can pick out the parts that you actually really want and run those instead. So I think that's that. Let's jump quickly back here and take a little bit of time to talk about a few other things. I'm talking a little bit about like developer experience for as far as testing goes, because that's sort of my more recent experience with testing. That's sort of where I've worked in the past, and something that I think is kind of interesting and not always talked about when we're talking about testing. If people have questions about this or are trying to put their project under test and have questions, that would be great. The next thing I was going to do is actually talk about golden tests and things like that. But before that, I did want to come over here. That's not the right thing. There we go. And talk about best practices. As part of this documentation, we also have links to some best practices for testing. This is going to vary a little bit depending on the project that you're working on. So depending on what you're building, it will change. But a lot of these are kind of more useful. I especially think this protection against regression is an important thing, especially if you have an outage in your service. If something happens, one of the most useful things you can do is just write a test that detects that. And this doesn't have to have like a code tie-in. It doesn't always have to be testing your code. You can also test your code in production. You can validate that things are actually executing as you expect in your production services to make sure that they're actually doing what you think they should be doing. For example, if suddenly all of your web requests start throwing 400, 500 errors, maybe something's wrong. And that can give you a hint that something is not going well. And you can actually use that to hopefully address the issue before you have a full outage. Things like that can be useful, but also tie into other parts of the practice, things like observability and telemetry and things like that. So there's that. We already talked about it being executable documentation. That's sort of, for me, one of the coolest parts of this. It gives you the ability to actually write something and that validates that it actually worked and sort of set in stone how things are supposed to work, especially when you're working with microservices. One of the most fragile parts of those microservices can be the contract boundaries. What that means, and I unfortunately don't have an example as part of this, is those edges of your API. So when we're talking about creating a JSON response for something, let me see if I have something here. I don't think this is done yet. Oh, it's over here. No. All right. So what an API boundary is that JSON result, that blob of data that your API is either going to receive or send somewhere else. One thing that can happen is ideally that should be fairly static. That shouldn't change that often. So you can actually build tests around that and use that as sort of your point to sort of isolate your service. It also saves you from potentially expanding the scope of your test beyond where you want it to go. But using that, you can actually validate a lot of extra bits about how your code is working and prevent downstream failures. So sending code that is perfectly fine in your own thing. So going back to like the sales thing, maybe asking for stock of an item. There's nothing wrong with sending a negative result from your API. That's probably valid, but downstream services might not like that. They might not know what that means, and they might not know how to handle that. And so that can actually trigger a failure further down the chain. That's a case where something like an end-to-end or integration test comes into play, where you're talking about an entire suite of tools to validate that something is happening. You can have unit tests that say, don't return a negative number, and you can have unit tests that say, if you accept the negative number, do this. But having the entire thing and validating that the experience still works across your actual application, when you've created something like that, and when that instance occurs, is a little bit different. So there's that. Let's jump back here. Less coupled code. We haven't talked about this, and we should. One thing that we've talked a little bit about in the past, as far as working with code, is dependency injection, or inversion of control. Dependency injection is an implementation of inversion of control. And what that means is, let's actually just create a class. Actually, I already have a class. Let's look at this. So we have our class here. What we're doing is injecting, or we're defining state inside of our object. Inversion of control would be giving another object the ability to configure that state. In this case, that doesn't really make sense, but this entire service here could be something that would be useful for being able to inject into some other thing. So being able to actually create and modify state. That's something that can be a little bit different. And I don't think I've gotten to that point yet. Let me just quickly check. Okay, we do have a little bit. So in this case, we are injecting a game state manager service, which is what we were just looking at. It's not done, so it's still a work in progress. But what this is doing is actually saying create an instance of this that is retrievable by other services in my application. The cool thing with this, and the reason this is kind of useful, is it means that a lot of your systems are no longer tightly linked together. So things that would typically say, create this, then do this, and then requiring lots of different things like a database connection or a specific web service. Instead, you can say, give me a data provider, some service that provides data. When that happens inside of your tests, instead, you can actually isolate out different parts of things. That becomes really useful for a lot of things. One of those is testing. It means that you can actually inject fake data directly into your application and say, what if this happens or this happens, without having to go and set up an entire database just to run your tests, because that causes some weird issues. It also gives you a little bit more of a decoupling between everything, which means that later on, you can swap things out. Maybe say, we no longer want stock service 1.0, we want version 2. Swap that in. And that way you don't have to take the entire thing down and send up an application update, you can just repoint it somewhere else. Those are kind of fun things that you can do as part of this inversion of control. So let's see. Yeah, we talked about this a little bit when we were doing flaky tests, is making things fast and isolated and repeatable. What that means is you shouldn't have tests that work sometimes and don't work other times. The tests we had where we were just using random numbers, it worked sometimes, and sometimes it didn't. And especially what you might see with that, we just use random. A lot of the times you might see it tied to some system characteristic. For example, expecting to be signed in as a specific user, or expecting some other specific like file to exist as part of that. That can cause other issues later on. And a lot of times it'll happen like after somebody has already pulled down the code or accepted it into production or something else. You don't want that usually. So another thing, code coverage. This is, I think there's a lot of mixed feelings about this as far as code coverage goes. It can be extremely useful, especially as you're just getting started. If you're working on a project, especially some of the legacy projects that I've worked on have not had tests or have not had very many tests. And so having code coverage as a metric to actually judge how you're doing as far as actually covering things can be useful. Targeting a specific number can prioritize things that you maybe don't need to prioritize. Again, we're getting back into the whole test can be technical debt. So be mindful of how many tests you're creating and whether the test is actually serving a value. My guess favorite tests are the ones that tell a story, that tell you, yes, the user can do this. No, the user cannot do this. This class will do this when you do this. Those kind of questions could be really useful. And then, yeah, this is going to talk a little bit about mocks and fakes. That is maybe outside of the scope of what I had intended to do. We talked a little bit about modifying things and talking about like inversion of control. Mocks and fakes gives you a way to swap out services, swap out different objects and dependencies with a different version of them, just to replace them with some interface version of them. So in this case, one of the ways that I'm doing this is with my game functions. In this case, these are SignalR things. So they provide the functions and the API layer for SignalR to send messages back and forth. But they're interfaces, which means that anything can implement them. And it doesn't have to be any one thing. What that means is that I can actually swap these entire classes out with fakes of something else. It's also why I'll use like IEnumerable, for example, instead of other things. It makes it possible to kind of swap these things out and replace them with less concrete implementations that behave in specific testable ways. For example, maybe I don't care what the game created function actually does. Maybe I just want it to set a value that says, yes, this was called, so that I know that this function was called once by my API. Because this is behind an interface, it's something that we can actually swap out. We can do that. There are more advanced testing frameworks that will give you access to mocking in more complicated ways. Those are really fun, but they're also going to be a little bit more than we can talk about here. I think there's there's more references here about how to do all of that. A lot of those mocking frameworks that are intended to give you additional tools to make that a little bit easier. Just relying on interfaces can be a little bit verbose because it requires you to implement classes. And the downside with that is that suddenly we need to implement this entire thing if we want to use it, which ends up being quite large. And that means your tests are going to be difficult. One difficult thing you'll run into with testing, going back to this, is that we want these tests to tell a story. to tell us what is happening inside of them. The difficult part with that is if they're very long. I mean, we had a few of these that were not long, but are getting to the point where if I scroll in a little bit more, they're no longer on the page. This is not a good example because I've tried to keep these short. But the useful thing with this is the entire test is on one screen. I can look at this test and see the entire thing right here, which means there's less mental requirements for actually thinking about what's actually happening here. If you end up with something that has hundreds of lines of code, that's really difficult to actually understand what the goal is doing and how it's actually working. It's also really difficult to maintain and actually make sure that things are still working. So that can be one of the downsides of having just interfaces, because then you'll implement something and suddenly you need to implement 20 functions because there's a bunch of things. It also means if we derive directly from an interface, anytime that interface changes, all of our tests need to be updated, even if the function that we're testing is not changing. And that can be a little bit extra. So let's jump back here and look a little bit at this. And I think this is mostly just covering mocking stuff. And if you are interested in figuring out more about this, again, you can go to aka.ms/testyourcode, and that will get you to this overview. And then from there, you can find a lot of this other stuff, including all of this. We do have suggestions for naming and things like that. And I think that's mostly that. I think that's mostly everything that we need to talk about here. One thing I did want to talk about, and one question that I have seen a few times, is testing older code. And so I talked a little bit about the idea of a golden test. That's what this is. So in this case, it's a predefined result. And then we're just executing a function and expecting to get that result again. So in this case, I'm doing some weird math. Oops, I'm breaking my code. It does this. This was just me having fun, but it does something weird, and I don't really understand this, and I definitely couldn't tell you, given 5, what is the result going to be? I don't know. So the advantage here, the thing that is kind of useful for a test like this, is I don't need to. What I've done is actually run this separately. In this case, I've actually gone and attached a breakpoint here and just run the debugger. So we do this and click debug, and you can actually run this code and see the result. See what's going to happen when you run your code, get a result, and then use that as sort of the assertion and just say, this should always be the same. This value should not change. And how it actually is executing isn't as important. The reason this is useful is if you're working with like an older project, something that has maybe no test coverage, it can be really hard to write that first test. And typically, the unit tests are kind of the hardest part, because if your code is not designed for unit testing sort of from the beginning, it can be really hard to start adding them because you don't have all those injection points to kind of put things in where they need to go. Instead, what you can do is run your code, whatever the application is supposed to do, run it, generate a result, serialize it to some file, do something with it, and then write your new updated modernized version of it and test against that. And that's sort of how this is working. In this case, we have an expected and we have our ID. So I can actually see the generated value that we expect from this, and I'm able to use that as our thing. So in this case, we're doing this version, and we're just validating that we get the correct result, the result that we expect. And everything else we can kind of make work. So we don't quite need to know even how this function works. And this isn't always a great idea. It means that updating and maintaining this application can be a little bit more difficult over time. But the really useful thing with this is if your test or if your code has some specific functionality, something that cannot change, you can write something that validates that without having to go and put your entire project under test or implement a modernized version and kind of guess that it returns the same results. This way you can actually kind of define that, especially if it's something that you know works, but you don't know how it works or why it works, and you don't really have the time to go through and figure out how all of that is happening. So one typical way I've seen this done, not doing this, is just with serialization. So ignoring this, we can just create a fact here that says public void test serialized data. And again, this is something that you would typically not use in a large scale application, even something like databases and things like that. I didn't really talk about this, but the idea of a golden data set, the idea of a golden test is you have some gold standard. In this case, I have explicit results that I'm expecting for a certain input. I am expecting those not to change. This can open a door to a whole bunch of problems if you just do this for everything. So there can be a little bit of a trap there, but it can be useful for these sort of cases. At least that's sort of how I found it useful in the past. But the idea here is you would have either a database, for example, going back to our idea of a store, you might have an explicitly defined shelf in your store that has X product with Y number of things in it. And your test is just saying, this database is always going to have that. It's always going to have this exact result. Here's the entire serialized database. It's large. Set up the store and do that before every test. The downside with something like that, especially when you're using a database, is things can write to that. Things can change it. So if you have a test that like inserts data and then fails, because it inserted that data or modified that data, unless you reset the database every single time, and that can be really slow and time consuming, unless you do that, it can cause other tests to fail that are actually executing correctly. And so it can actually hide the actual issue inside of your project. So that can be one of the downsides of doing a golden test. In this case, our scenario is more for using it for testing a legacy application. And I just think this is kind of a handy thing to know. A lot of the times you will end up having to do legacy updates because eventually everything is going to be legacy at some point. So you're going to need to understand how to do this. Luckily, testing has become more and more common, but in this case, let's pretend like we don't have a test. So what we can do is just create something. So let's say we have our object data. I don't know what I'm doing, but we'll just say, actually, let's just do strings. Strings equals new hello test. And so what we've done is we've said, here's our expected result. Hello test. We can run some sort of function that says our var result equals our new updated test generator. This will be a function. I'm just going to put it in the same thing. And so we can have our updated test generator. Generator, there we go. I can spell. And so we're just going to have this return some new thing. So hello new test. So if we expect these to work, if we say assert that these are equal of our expected result and our result, we would expect these to be the same. We're writing a test that would basically say these should be the same. In this case, that's not going to happen. These tests are not the same. And so this isn't going to work. But what we can do here is instead of all of this happening, instead of us doing this, what you can do is actually save this out to a file. In this case, we're just going to say expected or rather file, not write all text. And I'm just going to say write all text to our test.txt. I don't really know where that's going, but for this, that isn't particularly important. We're just doing this quickly. So all this is doing now is we're not even caring that we're running a test here. We're just creating a text file, and we're saying, here's our result. In this case, I'm doing it all in one place. But ideally, what would happen is this expected would actually be coming from your legacy app. It'd be coming from some untested code, so something that you needed to put under test and didn't really know how. This gives you a way to do that, because now you can just take your data, put it in a file, and say it should look like this. If it's not text, you can serialize it. You can just throw it through a JSON serializer and sort of do that. As long as you're expecting the same things to exist, you can compare them that way. So this would be like JSON convert dot serialize object, something like this. And so you would serialize your object into something. And this works for most rich data types, as long as the data structure matches. This gives you a way to kind of serialize that and then write it out to a text file. For now, we don't really care what the other bits are. We don't care how any of this works. We can just run this. We should be able to actually write this file out. There we go. Yeah, so it still fails, but that's expected, because now we have this and we're expecting it to be hello test. Again, the goal here is we want everything to be the same. But instead now what we can do is, instead of writing things out to this file, inside of our new updated app, we can actually just read all text. We can just read in the thing that we have done. Like this. There we go. And so what this is going to do now is take that text file that we just wrote out from whatever app, whatever data source we're trying to put under test. We can now use that. And again, this is intended to kind of show sort of that golden data set idea. This doesn't scale very well, but it is really useful for especially getting started with the testing scenario. So if your application is not under test, this can be a easier place to start. I don't know if that's necessarily the best word for it, but it can have a bigger payoff, because you can actually put actual execution results under test compared to something else. Think of it like testing an API boundary. You can put that entire thing under test instead of having to put tiny little functions, especially if your function happens to be thousands of lines or something else is happening, or you no longer understand how this works. You can give fixed data, plug it in, and get a result out. So now if we run this, hopefully, we'll get a result. And hopefully it'll pass. And if not, I'm out of time. So we'll be done anyway. But there we go. So now this test passes. And all it's doing is reading from that pre-configured output and comparing it to our new updated function, the new function that we wrote, and saying, are these the same? And in this case, they are. So now our test passes. That's kind of a handy little trick that I picked up when I was working on some app modernization stuff. I found it really handy. So hopefully one of you can use it. Anyway, that was sort of testing. If you're curious and want to learn more, again, aka.ms/testyourcode, that will get you here. And then from here, you can kind of go and find other resources, including links to the different testing frameworks that you might want to use and what's different between them and maybe why you should choose one over the other. And then from there, you can kind of get started. Whether you're working from Visual Studio or the .NET CLI, there's templates to get you started that will create your testing projects. And then you can use .NET Test to run those and get results. So hopefully this was useful. And I guess that will be it. So thank you all so much for watching. And I hope you all have a great rest of your day. So see you, everyone.